Okay, you've now clicked on the second part of the C1 Sequences and Series exam question booklet. We're moving away from the recurrence relationship type of questions now. So the first part asks us to write down the first three terms of the series. So we're just going to stick in R as 1, 2 and 3. So we've got 2 times 1 take away 5, which is minus 3. We've got 2 times 2 take away 5, which is minus 1. And we've got 2 times 3 take away 5, which is 1. State the value of the common difference. So if we do the second term, take away the first term, we've got minus 1 minus minus 3, which is 2. Part C says find the sum from the first term to the end term of this sequence and show that it is n bracket n minus 4. There's two ways we can do this. We know two formulas. Sn equals n over 2, 2a add n minus 1 d. We also know Sn equals n over 2 first term plus last term. Both ways you will definitely get n squared minus 4n at the end of it. So we know that a is minus 3, we know that d equals 2, and we know that n is n. We can find the last term by just sticking in n. So the last term is 2n minus 5. So if I do this way first, we have n over 2, 2 times the first term, which is minus 6, and then we've got d times n, so we've got 2n, and d times minus 1, which is minus 2. We've got n over 2, 2n minus 8, which is n minus 4, which is what we were asked to find originally. If we use this one, we've got n over 2, first term, which is minus 3, and last term, which is 2n minus 5, which leaves us again with n over 2, 2n minus 8, which simplifies to n minus 4. Okay, question 8. First 4 marks are the proof that you need in C1. So, if we're going to prove that Sn equals n over 2 2a n minus 1d, first of all we write out the first few terms added together. The first term is a, the second term is a add d, the third term is a add 2d. We go all the way through to the end of the sequence. The penultimate term is a add n minus 2d, and the last term is a add n minus 1d. If we reverse it, so Sn is also equal to a add n minus 1d, and a add n minus 2d. We go all the way through, a add 2d, a add d, and a. We add them, we get 2Sn equals 2a add n minus 1d, add 2a add n minus 1d. We will get this n times. So we can write that n lots of 2a n minus 1d. This equals 2Sn. So Sn is just n over 2, 2a add n minus 1d. Doesn't come up very often, but it is worth learning it. 4 marks, 4 easy marks. Okay. So moving on to part B, it says that Sean repays a loan over n months. His monthly repayment forms an arithmetic sequence. He repays 149 in the first month, so that's A, 147 in the second month, 145 in the third month. So D is -2, because he's paying back less each month. And we know that n is greater than 21. We actually want the 21st month. So for the calculation for the 21st month, we're going to use n equals 21. So to find the nth term, un equals a add n minus 1 d. For the 21st term is 149 add 21 minus 1 times -2, which is £109. So that's how much he paid. Part C, we're talking about a total here, and it's even giving us the equation that we're going to be proving. So we're going to use Sn. Sn equals n over 2, 2a add n minus 1b. We've got a is 149. We've got d as -2. And we've got Sn equals 5,000. We'll stick all this in and we get, let's go right down the way, make a bit of space I think. So we've got 5,000 equals n over 2, 2 lots of 149, add n minus 1 times -2, neatening that up, we get 198 minus 2n plus 2, neatening up again, we've got n over 2, sorry, that was 298, wasn't it? 300 minus 2n. We can divide this bracket by 2, so we've got 5,000 equals 150n minus n squared. And what we had at the start, we had to prove n squared minus 150n and 5,000. Okay, so that is part C where we had to prove it. Part D says we have to solve it. So it's not a straightforward double bracket, but with a bit of perseverance you get n is 50 and n is 100. Now part D says state with a reason which of the solutions to the equation is not a sensible solution to the repayment problem. Well, if we think about it, if he's going to pay it back after 50 months or after 100 months, he's already paid it off after the 50 months. So I would say that n equals 100 is not sensible because he's already paid off the loan. Okay, on to question 9, one of my favourites. Okay, Alice's birthday. On her 11th Okay, on to question 9, one of my favourites. Show that immediately after Alice's 12th birthday, the total allowances that Alice received was 1,200. Okay, so the first term is £500. The difference that she's getting every year is an extra £200. So on her 11th birthday, she got £500. On her 12th birthday, she got £700. So the total is £1,200. On her 18th birthday, this was the 8th term, so n equals 8, a equals 500, d equals 200, using un equals a add n minus 1 d, we get that the 8th term is 500 add 7 lots of 200, which is £1,900. Okay, part C, find the total of the allowances that she receives up to and including her 18th birthday. So n equals 8, a equals 500, d is 200, and because it's the total, we're using Sn. Now, because we know the first term and the last term, we could just use Sn equals n over 2 a plus l, or we could use the other sum formula, n over 2 2a add n minus 1 d. It's just as easy to use the first and the last. So we have 8 over 2, first term is 500, last term we just found out 1,900. This becomes 2,400. 2,400 multiplied by 4 is 9,600. Now, part D, when the total of the allowances that Alice has received has reached £32,000, the allowance stops. We need to find out how old Alice is when she received her last allowance. So we've got Sn equals n over 2, 2a add n minus 1 d. A is still 500, d is still 200, and this time we know that the Sn has reached 32,000. Right, so we put it all in, we get 32,000 equals n over 2 times 2a add n lots of d, so we've got 200n minus 200, so we've got 32,000 equals n over 2 times 1,000 minus 200 add 200n. This then gives us n over 2, 800 add 200n, multiplying this out and we get 400n add 100n squared. If we bring everything over to one side and divide by 100, we get n squared add 4n minus 320. We then factorise this to get n add 20 and n minus 16. So n is 16 or n is minus 20. Can't be minus 20. 16 years on, so we have that Alice is 26 years old. Thank you.